Thank you very much. I have great pleasure to present you some facts about CIVIC air quality monitoring in Serbia. So, European initiatives for citizens' inclusion in the air quality monitoring process led to the higher sense of community, stimulated discussions with policymakers, and influenced political decisions in the involved regions. Such experiment in the Republic of Serbia with self-made sensor kits, Klimerko Air to the Citizen, started in 2018. Klimerko monitoring devices measures air relative humidity, temperature, and concentration of PM suspended particles. It has not been calibrated since it was established that PMS 7003 sensors, PM sensors, are precise enough for civil measurements. At the moment, about 140 Klimerko devices are deployed on the entire territory of Republic of Serbia. A good part of them is located on the territory of the city of Belgrade. Our intention was to compare the PM readings from Klimerko devices to the readings of calibrated PM devices in the city of Bor and Belgrade in order to confirm once again the usability for indicative measurements of PM10 and PM2.5 in the ambient air. The results obtained by Klimerko devices were compared to the results obtained by the reference instruments located at the Serbian Environmental Protection Agency air quality monitoring stations, as well as with the calibrated air quality monitors that were located next to the Klimerko devices. The comparison of the results was carried out during summer and autumn in 2021. First, in Bor, we have compared the one Klimerko device with regulatory measurements from the air quality monitoring station. Between them, there was 500 meters. So the figure 2 that present comparison of hourly mean PM10 mass concentrations. We used the hourly results, and coefficient of determination was very good, 0.7. That was good. And on figure 3, you can see comparison of hourly mean PM10 mass concentrations between two local sensors in the city of Bor at the terrace. Pretty good results. Also, similarly for PM2.5 fraction, comparison between Klimerko sensor and referent GRIM ADM 180 referent instrument. Also very good coefficient of determination, 0.75. Also PM2.5 fraction, hourly means, between two local sensors. Also in Belgrade, Klimerko device was situated near restaurant Korčagin, and we compared that readings between that device and results from the GRIM monitor at the air quality monitoring station Vračar. That was very good coefficient of determination for hourly mean values of PM10. Also, time diagram, 1 month. Actually, 20 November is last day, very good correlation. Also for PM 2.5 fraction, correlations was very good. Coefficient of determination was over 0.8, and also that is presented figure 10. So, conclusions, the Klimerko devices that we have tested shown very good stability and reliability during the comparison period with the reference instruments. So the conclusion is that Klimerko devices could be applied for indicative measurements of PM mass concentrations in ambient air. Thank you very much.
Thank you, Risha, for excellent presentation. I have one question. You mentioned the percentage of explained variance for these local sensors. Do you have maybe some short list of what additional parameters could be maybe included to increase the percentage of explained variance for these low-cost devices?
I think that that sensor is very good, and I don't know how the results could be better, because that results was very good. Two different towns, two cities, two different sensors, so the readings are very close to reference instruments. And also one more thing, that sensor overestimated the both fractions for about 20%. That is good. It is good because it alarms earlier than it should be. So I think that it is a good device for indicative measurements of PM. Yeah.
Please, ladies first.
How it's come that you choose target?
Because that we have an citizen organization right up there. Yes, up there.
Which one? I asked that because of some other points.
I think some ecological organization. I don't know, because I'm not in. Yes,
yeah.
nearby. Yeah.
But so you really put in.
Yeah.
So from that point, why you compare it fracture? Because
it is very close.
It's not close. It is,
I don't know where is closer.
Exactly.
Not close.
Because station at Despoта Stefana.
No, it's not close.
No, but it's not. It is.
There is a traffic also. It should be problem.
It is, but it is about the same, and it is a little bit so. And so you average it half an hour, what you do?
Klimerko devices originally.
I know that what is Klimerko doing, but you
15 minutes averaged to 1 hour, and compared with yeah.
Okay,
Thanks.
Thanks, Bishop. We have one more question, really quick.
So, just a general thought. We are comparing devices working on scattering and more or less providing number. And in many presentations, I see that we measure PM, that is a gravimetric measure. Can be that we can change metric, and so go for number of particles instead of going to mass estimates, because all of us are always focusing on this PM, which bring, say, the bias of not knowing the density of particles. This is something that the scientific community should try to force. We are not waiting any more things. We are measuring in optical with high frequency, and this is something we should try to force.
Yes, it is also that.
But it is mandatory to calculate in micrograms per cubic meter. Also, it is very interesting how dispersed in that city it is different than in other cities. This structure of the particles, yes,
Yeah,
I mean,
content, yeah.
Bohr is
Industrial.
dealing with metal,
Yeah.
yeah,
so it is not the average density of.
is not
Yes.
the
I
same.
was measuring pig iron
yes,
production.
but we see the results. I expect something else, but
Yeah.
the
The
results
agreement
is
is excellent.
it's
What more?
interesting for me to say that, but yes.
It is also a situation that all that local sensors are not able to see anything that is below 300. So when we converted it in from number to mass, we do something
Adjust.
to adjust because that is.
Thanks,
So, Milos,
Misha. Thanks
I had-
everybody
Yeah.
for the nice
I
discussion.
had a question, Milos.
Saverio has question.
Saverio, please ask a question.
Yeah, very good question and a comment. Of course, we should be very careful in the use of indicative term because in Europe it is regulated by the EC 2008 directive. So if you want to, everybody will want to use the term indicative for our measurement tools, then we have to go through the evaluation of the expanded relative uncertainties, and we should be well under the limit. So the results that we have to show are not in terms of R squared or RMC or MAIA and others. We have to provide the expanded relative uncertainties. And another thing is the results appear to me a little bit surprising because they are very high in the coefficient of determination. So I was wondering what are, let's say, the distribution of the particles. So what are the averages of the particle concentration? Because this may skew the S squared because, of course, the 7003 from Plum Tower is very good at larger concentration, while it is a little bit blind at lowest one. So the question is, how much was the average concentration in the measurement case?
Milos, put in that screen on the. Can you?
Can you please share the screen?
Yeah.
That is.
This is a Belgrade situation last month. So the concentrations was very high, even for Belgrade.
Okay.
Also,
Okay. Thank you.
yeah. So
Sorry, quite high.
it's also surprising for me such good correlation, but that is no fitting.
But these are 15 minutes.
Hourly mean values. Yeah.
Take the average,
Yeah.
the daily average, everything.
Yes. That is the main reason why that.
Okay, thank you everyone. We must now proceed to thank you, Visha.